Right, so this is a video all about how my EB60 fourth gear keeps going wrong. So what I've actually done is I've got Brave and taken all of the bits off the drive input shaft. So the clutch goes on here, so that's what you see sticking out your bell housing. That part operates your first gear, I think, and then that is second gear, and I think that's for reverse. I am not a gearbox expert, so all of these bits go on this shaft from there to there, which I press them all off. Now the selector forks go into these gaps here and here. It goes like this. It's all going to fall apart. So that's sixth, that's fifth, fourth is under there, that's third. So if we just split some of this up for starters, so that's the selection mechanism for third and fourth. That one's a bit fucked. That's the problem with this gearbox, because third and fourth doesn't work. So we'll just put that there. But if you look at sixth and fifth, what happens is this sleeve gets pushed between one side and the other to lock the shaft in the middle on that taper there onto either sixth gear or fifth gear, because these are like free floating on the shaft. Now what happens is, as this selector thing slips over, it catches on these teeth. Let's have a little focus at this distance. Yeah, so there's like little cone shaped teeth that are part of what we call the synchromeshes. So if I take this apart so we can see into the synchro. Now this is like a conical surface, and as you push, so this will spin freely, but as you push it on, it locks onto the shaft. So what it does is it's like a friction device, so it sits freely, and then as it gets pushed on, it then brings the gear up to the correct speed, so it meshes, it synchronizes the gear to the shaft. Now let's see if we can get a good focus of that. If you'll notice, as I push that up there, there's a gap here, yeah, because it's bottoming out. Yeah, there are very, can we get a good focus on there? There are like little teeth in here. It's like machined with ridges in, and I think it's designed to like cut through the oil, because if these surfaces were smooth, there'd be a layer of oil and then they wouldn't bite. So what we do is we machine like really sharp edges. This is like a razor blade in here. So as it gets pushed on, it bites that gear and brings it up to speed. Gearboxes are like full of jingly jangly lots of little bits. Taking them apart is one thing, putting them back together is something I need to work on. So we've got a functioning fifth and sixth there, they work. So on this side, if we look at the damaged gears, first off, this selector piece, the teeth are getting absolutely annihilated on the edge of there, because as the synchro wears, this side's pretty good, if we can see, yeah, but that side is really gnarled up, because as the synchro stops working, we're forcing the gear stick more and more to try to get it to gear in, to drop in, and then we're chewing up this surface on this front face. So let me see if I can figure all of this out. That's going to be fourth. So that is supposed to bite onto there. Let's see if we can get a good focus picture of this again. Right, so as you notice, when we push that onto there, there's no gap. Yeah, there's your conical surface. So the teeth in there, if I touch them, they're literally, there's no teeth in here. It's flat and smooth. So those little grooves that are supposed to cut through the oil to bite onto that face aren't biting onto that surface anymore. So as they wear and you're just bottoming this out, it's not accelerating this gear up to a speed that it can mesh into, and what we're doing is we're just smashing all of the leading edge off all of here instead, because this is spinning and we're not dragging it to the correct speed to drop into gear. So we're just absolutely pummeling the edges of here against the surface of that. So those two are just, and that's that grind you can hear, where it should drop on, but it has to be at a matching speed to drop on. So this synchromesh, this inner surface is what does all of the magic. It's like a friction brake. I am not a gearbox expert, so I'm just saying what I see. Now, Mark has said that this synchro, third gear, has the same synchro size as fourth gear. Now, if we compare the two of them together, he could be right, because they're made out of different materials for starters, and fourth has got the grooves cut in it. Oh, come on, camera, focus. Right. So fourth gear's got like horizontal grooves, but third gear's got these like perpendicular grooves instead. And it's blatantly a different material makeup. So would third gear last longer than fourth? It's a good question, but it does look like it would fit. But I am no expert. They look like the same thickness. I was having a little measure before, and I think that will fit. So I don't know. Answers on a postcard. Who's going to be the first to build one up? Got to have a go, haven't you?